First of all, thanks all to inviting me to this conference. And what I want to tell you about is the X-ray transients on the ART-XC sky. And when we talk about the transients, we know that X-ray sky are very variable. So there is different types of telescopes now that could probe different types of transients. And on this diagram, you can see that there is some telescopes that cover almost whole sky every day, like MAXI or SwiftBot. And these telescopes are very well suited to catch rare and bright events, such as GRBs, soft gamma repeaters, X-ray novae, and so on and so on. And also there is different telescopes with narrow fields of view that are much more sensitive, and they can catch ubiquitous and weaker events, such as stellar flares, X-ray flares, off-axis GRBs, and so on and so on. And also, we can clearly see that there is some gap here, that no telescopes probe this region. And now the situation quite changed with ART-XC, because during its operations, it's mostly spent its time or in the all-sky survey, when we cover about 1% of sky daily, or in dedicated surveys, such as Andrew told about, when we cover about maybe 10 or 20 degrees per day. And so we can probe this region of not so bright, not so rare transients. And what could they be? Sorry. And so just a representation. So this is the part of the all-sky survey that was already published by ART-XC. And this is the part of the galactic plane survey that we spent more than a year now. So we just covered a thin part, maybe 2 degrees wide of the galactic plane of the whole galaxy. So now we can talk about what's going on in our galactic disk. And so this is the coverage of the artist imagination of our galaxy from the top. And there is where our solar system located. And the thin blue line is what we have achieved up to a certain luminosity with integral, now currently the deepest survey in the galactic plane, for over 17 years. And the red circle is what we can achieve with ART-XC during the single day in the galactic plane survey. So we can see that in the galactic disk, we can see almost all the matter, all the weight of our galaxy, and we can probe the different populations of the sources that reside in here. So this is for low luminosity end of X-ray binary. We can probe up to the 15 or maybe 20 kiloparsecs. And for brighter end of cataclysmic variables, we can probe something like few kiloparsecs. So we can see a lot of such systems. And if we will take the catalog of first year of the all-sky survey of ART-XC, these blue points show the sources from this catalog, and the red circles are the transients that we have discovered. And it's not too much transients, sorry for that, but still the size of the red circles here shows the distance. The bigger the circle, the closer the source. And we can see that there is a hint of two populations. So the series that around us and distant sources in the disk. I will not talk too much about cataclysmic variables, although they are very interesting, but we find them a lot. And this is two optical spectra of two magnetic cataclysmic variables. Probably they are both intermediate polars. For some of them, we already get additional observations. We see the pulsations, so it's probably we can be certain now that this is intermediate polars, and we now making such census of magnetic cataclysmic variables in the nearby galaxy. And for more rare systems, we're finding some peculiar X-ray binaries, and I will make some examples. So first of all, we found a new microquasar in our galaxy, and this is kind of interesting because the source actually went into the outburst in optics and was detected, but current classification schemes missed it. So it wasn't labeled as something quite interesting until we find it in X-rays with SRG, with ART-XC. And this is a very interesting system. It manifests itself in radio and optics, and it shows very weak optical to X-ray connection, not like other low-mass X-ray binaries. And it also has this wagging hard X-ray tail that we really like. So this system is still bright and still could be tracked with different telescopes. And this is maybe a peculiar one source, but the later population that we see now that are X-ray binaries with giant stars. And there's a few examples more. So how it started, we see some transient in this large area. We don't have very much pinpointing location possibilities with our telescope, but using other telescope, we can locate the source. And here we found this bright star, get the optical spectra, found the H alpha. So, okay, we can think that this is something with BE star. And then get follow-up observation. And surely we find pulsations at 7.5 hundredths of seconds and some pulse profile. But what is interesting that this system are relatively low luminosity. So it's a few times 10 to the 35 ergs per second in X-rays. This are low luminosity end for B X-ray binaries. Also, this system are quite interesting because it certainly went through this close episode and then brought it back. And this system located on the northern sky and on the southern sky, we find another nearly similar system. Once again, got this localization, got spectrum with salt here, and this is prominent and beautiful H alpha line. So it's another one BE system. And once again, it has pulsations at 500 seconds, low luminosity, nothing remarkable in the pulse profile, but what is remarkable, it has more or less flat spectrum in hard X-rays, and now we do think that there is a certain class of B X-ray binaries that show two humped spectra. So there is different systems. All of them are low luminosity, so they have luminosity about 10 to the 35 X pair, GX304, and so on. And so we now, with ART-XC, discovering such systems in galactic plane at larger distances, and we do see that they are long period, and this is quite interesting, because if you take the Corbett diagram, so there is for high mass X-ray binaries dependence of neutron star spin against the orbital period of the system. And these orange polygons are systems detected by ART-XC. And now we are populating this high right end of the plot with the systems that are slowly turning in hundreds or thousands seconds and have a relatively wide orbit. Not all orbits here are accurately measured. We are still working on it, but it's evident that we are probing this far region. And also, there is not only systems with blue giants, such as the X-ray binaries, but also systems with red giants. Another one of the systems, we catched it in X-rays, and our colleagues from the United States we managed to get this beautiful spectrum in EIR, and so there is a lot of absorption features, and they classified the system as a mirror hosting symbiotic X-ray binary. And this is another one very interesting class of X-ray sources that are, we know, they are very transient in X-rays, and they are not that common as we think. We expect to have about 200 such systems in our galaxy, and we now know for sure only about two dozens of them. So there is still a lot of such systems missing, and they are very tricky to study because they are often heavily obscured. And so this system showing this interesting behavior, it went through the dust formation episode a few years ago, and then this dust envelope expanded and eventually reached the neutron star that orbits around it, around this old red star. And now this star accretion, neutron star accreting this dust envelope and producing bright or relatively bright X-rays. So symbiotic X-ray binaries are another type of transients that we are now keeping our eyes on. And
2 minutes.
Yeah, of course. And to conclude our talk, so what we are catching in the galactic disk? We are catching peculiar X-ray binaries, of course, but they are not so frequent. We are catching a lot of low luminosity, high mass X-ray binaries. And this is important because we are extending integral population down to the lower luminosities and to the far corners of our galaxy. And we are now catching the X-ray, symbiotic X-ray binaries, which are not so common for us now. But we expect to find a lot of more of such systems in galaxy. And of course, we are complementary as a survey to other missions. And what should I also add? Public domain optical surveys that now widespread are extremely useful for X-ray transient community because we can select our optical counterparts based on variability or maybe available spectra. So this makes our lives much easier. So that's all for me. Thank you for attention.
Thanks, Ilya.